Hello, welcome to the Bakwas channel for self-paced tutorials on Internet of Things. This video demonstrates the use of Open WebUI by individuals without deep technical expertise to work on AI-related tasks. Open WebUI is a versatile browser-based interface for running and managing large language models, LLMs, locally, offering Jetson developers an intuitive platform to experiment with LLMs on their devices. It can work with Ollama as a backend, as well as other backends that are compatible with OpenAI, which can also run well on Jetson. It is extensible, feature-rich, user-friendly, self-hosted, and has the most important feature: it is offline capable. It runs on Jetson devices, including the Orin Nano SDK. We will examine a basic deployment scenario to keep the introductory tutorial simple. You may, however, choose to explore other deployment options with the documentation at the Jetson AI Lab. Finally, we will illustrate a beginner's version of Retrieval Augmented Generation, RAG, to help you to ramp up the learning curve on piggybacking your own models using the shoulders of the giants in the industry. The benefits of Open WebUI are extensibility. It's built to be adaptable, allowing for integration with various LLM backends that are compatible with the OpenAI interface, such as Ollama. It's feature-rich. It includes a range of functionalities to enhance the user experience with LLM. User-friendly. It aims to provide an intuitive and accessible way to interact with artificial intelligence solutions. Self-hosted. It is designed to be run locally to provide enhanced privacy. Runs well on the Jetson devices. Offline capable. It is designed to be able to run entirely offline. Unplug the Ethernet cable to the Jetson device, and don't be surprised that the Open WebUI continues to run. So let's look at some of the ways Open WebUI offers extensibility. You can have custom models. You can have custom UI components. You can have custom prompts. And of course, you can have custom data sources, especially when you're using Retrieval Augmented Generation or RAG. The key features of Open WebUI are LLM runner support. It supports popular LLM runners like Ollama and OpenAI compatible APIs. This flexibility allows users to work with a variety of LLMs. RAG integration. It includes built-in Retrieval Augmented Generation, RAG, capabilities, which improve the accuracy and relevance of LLM responses by allowing them to access external information. Focus on local LLMs. A large part of the project is designed to allow users to interact with LLMs that are run locally on the user's own hardware. Web interface. It provides a clean, modern web interface for chatting with LLMs. This slide examines the prerequisites for running Open WebUI on NVIDIA embedded devices. While a similar approach will work for Raspberry Pi computers, since I do not have a Raspberry Pi 5 with a CUDA compliant hat, please give me some liberty to limit this demonstration to Jetson devices. I know that there is the Halo board for the Raspberry Pi 5, but I do not have one in my current IoT farm. So naturally, we will need one of the following Jetson devices: Jetson AGX Orin, 64 gigabytes, Jetson AGX Orin, 32 gigabytes, Jetson Orin NX, 16 gigabytes, and Jetson Orin Nano, 8 gigabytes. For this demonstration, we will use the last one, the Orin Nano SDK. The chosen device must run either Jetpack 5 or Jetpack 6. The Orin Nano SDK can be upgraded to Jetpack 6. This is particularly important if one is using the tutorials published by NVIDIA in their Jetson AI Lab section of the website. We will discuss ways to confirm this presence of this release or a later version shortly. A non-volatile memory express NVMe device, namely solid state drive SSD, is highly recommended for storage speed and space considerations. A slow and capacity-limited microSD card will be a bottleneck even for basic tutorials. The size of a single Open WebUI container image is 7 gigabytes. You will need quite a bit of space for the models too. The Jetson Orin Nano SDK has 3 NVMe slots. We will use the M.2 2280 slot. This slot is 22 millimeter wide and 80 millimeter long, hence the 2280 designation. Before we can run the Open WebUI tutorial, we have to fulfill a few prerequisites. The first one is obviously the fact that we're running on an Orin Nano. Secondly, running Jetpack 6, and of course we need some adequate storage for the container and the model spaces, so we need an SSD. The simplest way to check whether we're in an Orin Nano is to run neofetch and look at the host information. It says Jetson Orin Nano. The other things that will tell us is CPU and obviously the kernel and the installed OS. This should be sufficient clue for us, but let's say for the sake of discussion, but if we want some more information directly because we don't have neofetch installed, then we can do the old-fashioned way for single board computers is to run the CPU in 4, and that gives us basically just the CPU information, which is not enough. So let's run another command, and this time we will explicitly invoke the Jetson hardware string if available. So once I give in my sudo password, you can see it's confirming that we do have Jetson Orin Nano. The next step is to see whether we have Jetpack 6 installed, and the simplest way to do that would be to just run the Tegra information, and here's the command for that. And the telltale sign is R36. This is only available through Jetpack 6. If you want some more information about the kernel, we can always try the standard Ubuntu method, which is to run lsb release, and that tells us Ubuntu, which is what Jetpack 6 runs on. So obviously if Ubuntu 22.04 is installed, the chances are that Jetpack 6 you would have installed separately. The third and the last one is whether we have SSD storage or not. And for that, we'll just look at the hard disk layout. And you can see I have a folder called SSD, and that's non-volatile memory. And obviously, it's a pretty large one, approximately 1 terabyte available. And I've already used 17% with all the files that I've downloaded. So we fulfilled the requirements for running Open WebUI. For the demonstrations in this tutorial, the Open WebUI application will run in a Docker container. Ollama can be run in 3 ways. The first mode is to let Ollama run as a background service natively on the Orin Nano. The second mode is to launch Ollama as a Docker container prior to launching the Docker container for Open WebUI. The third mode is to launch both containers simultaneously with the Docker compose command, one container for Docker and the other for Open WebUI. Since we already have Ollama up and running as a background service, owing to the previous tutorial work, we will select the first mode and simply launch the Docker container for Open WebUI. Our Jetson already has Ollama running in the background. If I type in Ollama, as you can see, it responds. So Ollama is running as a service, and we don't need to run it in a separate Jetson container. Now, the other Open WebUI can be run in the container and leverage the Ollama backend. So for the command for that, let me go ahead and paste it in here. You can see that we're going to pull in Open WebUI, and we will designate port number 1134 in here as the port for our browser to point to. So let's just go ahead and run this, and it's downloaded it because it's already present on the system, and the container is up and running. So we are going to go ahead and point our browser to the address of the Jetson and specify the port number from a remote desktop. Since Ollama is running in the background as a service, we need only run the Docker container for Open WebUI. The command for this operation is shown on the slide. We will discuss the command parameters in the next slide. The / character signifies the command line continues on the next line. Please note that the volume information is specific to the current tutorial. The SSD on the current Orin Nano SDK is mounted as a folder with the name /SSD. Here is the description of the command line options. -D runs the container in the background, that is in detached mode. Docker starts the container and then immediately returns control to the terminal so that you can use your terminal for other tasks while the container runs in the background. --network specifies the network connection for the container. In this example, the container will use the host machine's network stack directly. -v permits the container to leverage the host computer's file systems. Data within a container is lost when the container is stopped or removed. Using the host file system permits the data persistence even when the container's life cycle ends. -e allows environment variables to be passed to the container. In this example, the URL for the Ollama backend server is being passed. Other use cases are database connection strings or API keys. --name allows you to assign a name to the container instead of a random and whimsical name. It amplifies the container management. --restart parameter is used to define the restart policy for a container. In this case, the container will always restart, irrespective of any previous exit conditions owing to errors. -p allows the traffic on a port in the container to be redirected to another port on the host. Of course, in this example, the numbers are the same by choice. So OpenUI is running at this address. I'm using the fully qualified domain name of the Jetson. I could use the IP address as well. And the port number is 8080. The first time when you log on, it's going to ask you for credentials. And you can create your own credentials, or if you have existing ones, you can go ahead and sign in. In this case, I already had an existing credential, and I signed in. So normally, what we want to do is look at all the models that are available under OpenUI. And we can go and click here, or we can go ahead and select from the drop-down list in here, and it's going to come back and give us a list of models that are available under Gemma, for example. You are required to register when accessing Open WebUI for the first time. The credentials are stored locally and never verified externally. Some of the introductory topics that we will cycle through in this tutorial are basic chat interface and model selection, understanding and using system prompts, chat history and saving or loading conversations, simple settings and customization, and finally, Retrieval Augmented Generation, RAG. Let us go ahead and launch Open WebUI. So I'm going to go and create a new tab in here and type in the address for the Jetson. And it's on port 8080, as you saw when I created the command. And this is the landing page, and at the bottom it says get started, which I click. And right away, we have to go ahead and create the credentials. Since these credentials are not validated externally, we can just go ahead and type anything that we want in here, and it'll stay local. And I'll just use a password that I can remember easily. And we create the admin account. And obviously, initially, there'll be information about what's going on. And then we go past that. we can go ahead and on our default, we're loading Gemma 3, the 4 billion parameter model. Let us look at the core functionality of interacting with an LLM through the web interface. The key elements are: demonstrate how to select a model from the available list, show how to type a prompt and send it to the model, explain how to read the model's response, and finally, illustrate the basic chat history and navigation. System prompts influence the model's behavior and responses. Therefore, we should spend some time understanding it to become more productive. The system prompt settings you can edit these as you see fit. The default persona is the response as a helpful AI assistant. This is the default behavior with no system prompt. System prompts act as powerful tools to customize the behavior of LLMs. By carefully crafting system prompts, you can tailor the model's responses to specific needs and preferences. However, it is important to remember that the model will try its best to follow the system prompt, but it is not guaranteed to do so perfectly with every response. Let us look at some simple examples of system prompts to illustrate different facets of LLMs for your custom use. The first example of a system prompt is the role-playing a historical figure. System prompt: you are Carl Sagan. Respond to all questions as if you were him, using his speaking style and knowledge. User prompt: what are your thoughts on interstellar travel? The system will attempt to answer in the celebrated style of Carl Sagan, incorporating his classic phrases and perspectives. The second example is that of a creative writing persona. System prompt: you are a science fiction novelist. Craft your responses as if you are telling a story. User prompt is: describe the city of Shangri-La. The system will give a descriptive, narrative response as if it were writing a scene in a fantasy novel. By carefully crafting system prompts, you can tailor the model's responses to specific needs and preferences. Let us look at the use of a historical figure in the system prompt. So if we go to chat controls in here, and in the system prompt, we can type in, you are Carl Sagan, respond to all questions as if you were him, using his speaking style and knowledge. And now let's post the question, which is, what are your thoughts on interstellar travel? So I'm going to go ahead and type that in here and see how Gemma responds. So go ahead and hit the enter key. And it's processing, and obviously it's going to take a little while because I used a system prompt, and so it has to reformat it in the framework of Carl Sagan. So here comes the answer in the way that generally Carl Sagan would respond. It's breathtaking, isn't it, to contemplate the sheer scale of the cosmos and the possibility, however distant, of traversing it, and billions of galaxies. So I hope you get the idea that we can make it respond by changing the system prompt. So what I'd like to do now is move on and use a creative figure and see how Gemma responds through Open WebUI. So let's change the system prompt, and this time, instead of Carl Sagan, we'll say you are a science fiction novelist. Craft your responses as you are telling a story. And so let's go ahead and say, describe the city of Shangri-La as our request. And so I'm going to go ahead and type that in here and see what it does. And as you can see, it's very creative in the way that it describes it in a colorful way. And remember, you can save this information, you can export it, and you can use it elsewhere. Or in some cases, you could even use it to feed it to another creative arts program and generate images, paintings, or even videos. And it's a fairly lengthy response, which tells you clearly that it is very comprehensive in the way that it understood the system prompt and responded accordingly. So I think that's not for now for system prompt examples. The default behavior of the model is to provide general information or complete tasks as requested. The model can be tasked to format the responses. System prompt: you are a recipe generator. Provide all recipes in a numbered list format. The user prompt: give me a recipe for paella. The model will provide the recipe in a numbered list, making it easy to follow. The model can be tasked to restrict the response. System prompt: you will answer with single sentence responses. User prompt: who is better, Ronaldo or Messi? The model can respond in another language. System prompt: you will only respond in German. User prompt: are Germans emotional? The system will respond in Deutsch. Das System antwortet auf Deutsch. Let us format the request from the system. So we'll go ahead and tell it that you are a recipe generator. Provide all recipes in a numbered list format. And our request is for a recipe. So we'll go ahead and type that in and say, give me a recipe for paella. And then submit this. So here comes the answer. And as you can see, it's formatted very nicely like a recipe. And once again, you can export this and save it to your recipe collection or your cookbook file, wherever you want to keep it. But you see how it changed the format of the reply based on your system response. So I'll let it run so you can watch how a paella recipe is made possible through the courtesy of Gemma through Open WebUI. As we remarked in the slides, we can ask the system to restrict the response. So we're going to tell it to respond with only a single yes or no sentence, a short sentence. And the classic question, for which there is endless debate on the internet, is who is better, Ronaldo or Messi? So let's go ahead and post that question and see the kind of answer that we get. So obviously it's a diplomatic response, but look at the length of the sentence. It does cover, we said single sentence, and yet it had to go beyond it because generally it's very difficult when you're comparing Messi and Ronaldo. So short sentences for each, but clearly no conclusive answer because the debate will go on as long as both are playing, which of course the curtain is coming down very shortly, in a year or two perhaps, maybe. Let us review conversations in a chat session. For basic chat interaction, we can engage in a simple conversation with the model by asking its name. The user prompt is, "Hello, what is your name?" The response from Open WebUI will be shown shortly. We can ask the same question in some of the other popular languages too. We could also constrain Open WebUI to respond in a specific language that it supports. Another user prompt is, "Tell me an adventure story." The response will be a different interaction, naturally, as we shall see shortly. Let us start a basic chat session with Open WebUI. Although it's not necessary, I just want to illustrate how we can go about doing a basic chat session by asking it its name. So the user prompt is, "Hello, what is your name?" And Gemma will come back with a response. As you can see, the response is back in the language the prompt was typed. So we can try another language, and in this case we'll go settle for French and type in, "Bonjour, quel est ton nom?" So let's see what the response from Gemma is going to be. It's in French. "Bonjour, je m'appelle Gemma. Enchanté de vous rencontrer." So you can see that it's still learning French, and obviously there will be some imperfections. We can now switch over to another language, and as you can see, it takes it in its stride and will respond in German. "Hallo, wie heißt du?" And it comes back with a quick response. "Hallo, ich heiße Gemma. Freut mich, dich kennenzulernen." And the next one that we'll use is Spanish, and try to say, "Hola, ¿cómo te llamas?" And let's see how it responds quickly. "Hola, me llamo Emma. Es un gusto conocerte." So let's go to another language, and in this case, Mandarin, in the simplified Chinese version. And we'll go ahead and say, Ni hao, kunchun ni jiao sheme mingzi. So it comes back with a ni hao, and it obviously gives the same answer as we saw before for English, French, and German. So one more attempt, and this time in Japanese, and you can see it'll support that too. So we'll go ahead and put it in Japanese, and the reply comes back quickly. Konnichiwa. We can now change the user prompt, and in this case, we will say, tell me an adventure story, and see how the narrative spins out. So as you can see, it starts off immediately and goes ahead and produces the start point of a story. And this can continue, and you can interact with it and refine the dialogue either through system prompts or some additional messages. And naturally, it's completely different from the original question, which was, hello, what is your name? So it's going to continue for a while. I'll just go ahead and pause the video now and move on to the next slide. So at the end of the output, the system comes back and would like to know whether you want to continue with the story, or you want a different story, or you want to tweak. So these are some of the interactions in a conversation that you would normally have. And here is a perfect example how in the large language model, you can do something similar. So this is very helpful. And my suggestion to you is to try and explore some of these options on your own, in your own environment. Notice that the conversation is displayed in chronological order with user prompts and model responses clearly separated. There are some visual clues that distinguish the messages. The history is persistent for the current session, and you can scroll back to review preceding discussions. In addition to scrolling up and down for the chat history, there are other parts of the history that you should keep an eye on during your session. If you create a new chat, the current chat history is cleared to start a new conversation. You may want to save a chat so that you can reload it. The history is restored when you reload the chat. Of course, you can use the saved chat in other tasks external to Open WebUI. Chat history provides a context for the AI model, allowing it to maintain conversational coherence. You can refer back to previous interactions to review information or continue the conversation. The ability to save and load chats allows for the persistence of conversations. Hopefully, you now understand how to effectively manage and utilize chat history in Open WebUI. Open WebUI, while designed for flexibility and power, also aims to provide a user-friendly experience with simple, accessible settings. Some of the basic settings are theme selection, chat management, user interface, UI options, and model parameters. You can personalize the visual appearance by toggling the light or dark modes. You can also use basic color scheme options, for example, minimalist or high contrast. You can control the current chat sessions with buttons like clear or new. The user interface options allow you to change how the user interface reacts. For example, the auto scroll checkbox controls if the chat window automatically scrolls to the newest message. You can control model parameters like temperature and max tokens. Temperature controls the randomness of the model's responses. Lower values are equal to more deterministic, and higher values are equal to more creative responses. Max tokens slider controls the maximum length of the model's response. The save and load buttons, as the names imply, saves the current chat and allows you to select previously saved chats. These settings do not require prior AI experience. They provide immediate, noticeable changes to the interface or model behavior. The key sections in a basic RAG functionality are indexing or knowledge base creation. Here we have data loading. This involves ingesting data from various sources, documents, web pages, databases, etc. We have data processing, which is cleaning, normalizing, and formatting the data. Then we have text splitting and chunking, dividing the text into smaller, more manageable segments. And then embedding generation, converting the text chunks into numerical representations, vectors, using a model. And finally, in this section, we have index storage, which is storing the vectors in a database that supports efficient similarity search. In the next phase, we have query processing and retrieval. Query input, the user's question or prompt. And then we move on to query embedding, which is converting the user's query into a vector representation using the same embedding model used for the indexed data. And then similarity search, where we perform a search in the vector database to find the most relevant text chunks based on the similarity between their vectors and the query vectors. Finally, context retrieval, fetching the original text of the retrieved chunks. And then we move on to the final phase, which is generation, prompt augmentation, combining the original user query with the retrieved relevant context. LLM input, feeding the augmented prompt to a large language model. And finally, response generation. The LLM generates a response based on the combined information from the query and the retrieved context. Some of the benefits of these key features in Open WebUI are accessibility. They are fundamental to using Open WebUI effectively. Ease of understanding. They are relatively simple to grasp for beginners. Practicality. They enable users to start experimenting with LLMs immediately. Foundational. They build a solid foundation for exploring more advanced features as one ramps up the learning curve. Before we can upload data, we must prepare with two requirements in mind. The chosen model must support Retrieval Augmented Generation, RAG, and it must have text, PDF, or CSV files or URL for import into the augmented model. Open WebUI has several options to manage data sources, knowledge base, documents, ingest, or vector store. Please note, future releases of Open WebUI may rearrange the location of these options on the web page. Select an option to upload new data, for example, add new data source, upload files, import data, or select the plus icon. Specify your data source type: upload files, web URLs, text input, or other connectors. Upload the data using Upload Files option for files, or add or import web URLs for text. After the data has been uploaded, Open WebUI will process it automatically. The key steps in the process are text extraction, chunking, embedding, and indexing. In text extraction, extracting text content from the specified sources like PDF files. Chunking is the process of dividing your large uploaded data, for example, documents, articles, web pages, into smaller, more manageable segments called chunks. LLMs have a limited context window, meaning they can only process a certain amount of text at once. Large documents often exceed this limit. Chunking allows you to feed relevant portions of your data to the LLM within its capacity. Smaller, focused chunks are more likely to contain information directly relevant to a user's query. Embedding smaller, semantically coherent units leads to more accurate retrieval. Embedding is the process of converting each of these text chunks and also the user's query at retrieval time into a numerical vector representation. These vectors capture the semantic meaning of the text, placing similar pieces of text closer together in a high-dimensional space. Embeddings allow for semantic search. Instead of just looking for keywords, you can find chunks of text that are conceptually similar to the user's query, even if they don't share the same exact words. In indexing, the generalized embeddings, along with the corresponding text chunks and metadata, are then stored in a specialized database optimized for vector search. This is often referred to as a vector store or vector database. Indexing in this context means organizing these vectors in a way that allows for efficient similarity search. Common indexing techniques include nearest neighbor search, NNS algorithms. These algorithms allow for quickly finding the vectors in the database that are most similar in a query vector. Examples include approximate nearest neighbors, ANN algorithms. Data structures and organizing the vectors in structures that facilitate fast retrieval based on similarity, for example, trees and graphs. If a progress bar is displayed, wait for it to complete. Once the processing is complete, specify the data sources you wish to be used to process your questions. There are several toolbar options for this purpose, and you may want to use all available data sources. Ensure that your newly uploaded data is selected or enabled. Now ask the language model the questions that can be answered by the information contained in the uploaded data. Notice that when you ask a question, Open WebUI will generate an embedding of the question. Search the vector store for the most similar text chunks from the uploaded data. Retrieve these relevant chunks. Augment the language model's prompt with these retrieved chunks. The language model will then generate an answer based on both its general knowledge and the specific information provided in the retrieved context. The model's answers are formed by the content of the uploaded data. The response will include information from the uploaded data. The RAG process uses this information to generate a more accurate and context-aware answer than if it only relied on general knowledge from the main model. For troubleshooting, for example, data not showing up, if the data doesn't seem to be used, double check that it was uploaded successfully and that the correct data source is selected through the Open WebUI interface. Poor answers. If the answers are not relevant, then refine your questions and ensure that the uploaded data contains the information needed to answer them. The quality of the embeddings and the search algorithms play roles too in the query. For processing errors, if there were errors during the upload or processing stage, Open WebUI might display an error message. Check the logs for related error messages. Let's do a very simple Hello RAG demonstration. So we will log into Open WebUI with our existing credentials. And once we log in, on the left nav pane, we might not see the choices. So we click on the hamburger menu and we drill down to workspace. We need to create a new workspace for our work. And once we select that, the toolbar menus change, and we want to create a new knowledge base using documents that are not part of the current Gemini model. So we click on knowledge, and on the right-hand side, we select the plus button to create a knowledge base. We will give the knowledge base a name, and in this case, I will just say the name for this is Into the Deep. And the purpose of this is really to assist referees during a match. And once we're done, we click on the button, Create Knowledge. Now we have to go ahead and upload the document. So there is nothing in the system now so we will click on the plus button and we will upload some files. The first file that we want to upload is the competition manual. So we select that, it's a PDF file, and the system starts processing it immediately. Once the file is added, we can go ahead and add the second one, which is the field setup, and I'll go ahead and select that, and it starts processing it. So that file too has been added, and now we will move on to create a new chat to work with this knowledge base. So we click on New Chat, and before we can do anything in terms of our user prompts, I'd like to set the system prompt up here and say respond as the head referee. So now we can go ahead and ask a question. And by the way, I've implicitly used the default model that we have here called Gemma. You could choose some other model if you wanted to. So what is the difference between pinning and blocking? This is a common question that we have to struggle with during matches. So we get the answer pretty much in a detailed manner. And as you can see, it's giving us a good explanation, but not clearly telling us whether it's a major foul, minor foul, or a non-issue. So we will have to refine our user prompt, but this is just one simple demonstration. What I'd like to move is go ahead and show another aspect of it. Okay. So as you can see, it's now, since most of you cannot relate to this kind of match, I think it's a little academic trying to drill into the details of the explanation. What I wanted to do was illustrate to you that completely out of the blue, we took some documents, added it to our knowledge base, and we got some meaningful answers using the LLM functionality of Gemma. Okay. So another question is we can ask clearly, is pinning a foul or inconsequential, which means it's not a foul, basically is what we are trying to ask. See, as you can see, pinning is not a foul, and it can become a foul if there's a time period. So as you can see, it's giving us a good explanation. And when we have, referees are generally volunteers in these matches, and they don't spend time reading the manual. So having access to this kind of information readily online for them to interactively get their answers is really very helpful. And just one very simple facet or example of how RAG can be used to help you on the backs of an LLM model. So these questions are the answers have been retrieved from the 2 documents that we uploaded, but the LLM part, formatting the message information, all these things clearly are coming from Gemma. So I hope this has been a useful introduction to you on how easy it is to get started with RAG. You have a working LLM model, you create the workspace, you add files to the knowledge base, and you start a new chat. You may or may not want to change the system prompt, and then of course you keep refining the user prompts till you get the type of answers or you satisfy yourself with the responses. Please do take the next step and work on RAG, because it is very easily done in any environment. This short tutorial demonstrated the installation and use of Open WebUI, performed simple examples to illustrate the key features of the user interface, introduced Retrieval Augmented Generation, RAG, to improve LLMs by bridging the gap between the vast general knowledge of an LLM and the specific, up-to-date, and authoritative information required for many real-world applications. RAG makes LLMs more reliable, accurate, and adaptable by grounding their responses in external evidence. That's all, folks. Thanks for taking the time to view this presentation. Would love to hear from you with your feedback. You are always welcome to be critical in any which way you can. Until next time, bye for now. This presentation was prepared with assistance using free open source software, FOSS, from the Ollama team, the Open WebUI team, and for the backbone of the preparation of this tutorial from OBS Studio, Kdenlive, LibreOffice, and of course, Ubuntu. Teachers, viewers, and peers provided valuable feedback. My apologies if I have inadvertently omitted anyone from this acknowledgement. A very big thank you to y'all for the assistance.